Okay, so welcome. And so today we're going to start talking about improper integrals. Okay, so to start with, let's have a little discussion. So in this example here, let's take this function f of x equals 1 over x, and we're going to take the interval from 1 to positive infinity. So the question is does the area under the curve over this interval, is it finite or is it infinite? Okay. What if we revolve this function around the x-axis? What if we revolve this around the x-axis here and we get a solid of revolution? So let's assume that we get, when we do that, we get a solid of revolution. Okay. Now, so here's another question. So is the surface area of that solid of revolution, is that finite or is it infinite? Is the volume, what about the volume created, the volume of that solid that's created by revolving this function around the x-axis, is that finite or infinite? So those are good questions to ask. Now, the interesting thing about this particular one, actually this is called, this is referred to when you take this function and you revolve it around the x-axis from x equals 1 to infinity. This is called Gabriel's horn. Okay? Now, the interesting thing about Gabriel's horn, and well, this function in general, or specifically, is that the area of this region, the surface area described, is infinite, but the volume is finite. Okay? So if you revolve this around, and the reason why it's called Gabriel's horn is because you get something that looks like a horn, one of those real long horns that they used to have a way long time ago. So, so this is called Gabriel's horn, and it has a finite volume but an infinite surface area. Okay. So again, so how do we know what to do? So these types of integrals that we're talking about are what we call improper integrals. So anytime that we take a value, the starting point from a to infinity, are called improper integrals. Now, so in this section, what we're dealing with, they're not just integrals that go off to infinity. So one or both of the limits of integration are infinity, right? But also we're going to consider integrals where there's a discontinuity along the integration. So if it contains a discontinuity anywhere, we're going to talk about that. Or if there's a discontinuity at one of the endpoints, we're going to consider that as well. Okay? Or if there's a discontinuity in between. So all of those are examples of what we are going to term as an improper integral. Now, how do we define an improper integral? Well, let's look at this. We know that we could take an integral, for example, if we look at this graph, we know we could take the integral from any a to any t value, right? So we can find the area under the curve for any t value. And so what happens if we start making t bigger, right? So the area gets larger, but as we can see, the tail is getting smaller and smaller and smaller. So the amount of area that we're adding to the total is changing, but it's also the amount that we're adding is getting smaller. So one way, what we could do is, one way we could define this is using limits, right? So what we could do is, what if we take the limit of this integral, right? So we know we can take this integral, but what if we keep moving t bigger, 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 and we take the limit as t approaches infinity? So, in other words, we can define this integral, or this integral rather, we can define this as, oops, maybe give myself some more room. So we could define this as the integral from a to t, let's say. Oh, I'm getting ahead of myself. The limit as t approaches infinity of a to t of f of x dx. So we can take this and we can define it as a limit. The limit of this integral, so the limit of the area under the curve, right? We're taking, okay, where's this area going? It's a sum, right? And we're adding to the sum, the total. So is it converging to a particular value, or is it diverging to no value? So we're going to let this increase without bound by taking the limit and see if this approaches a certain number or if it doesn't. Okay? And now that's where I'm going to stop. So in the next video, I'm going to introduce the definitions. Okay, so we're going to talk about the definitions of improper integrals, and we're going to make it more, we're going to make it stricter. Okay, so I'll see you then.